Okay, today we are going to talk a little bit about how to build our solar charger with our solar panels. So, as an electronic engineer, your task is to create and design electronic devices and electronic circuits with many components that sometimes are going to be necessary to study them in depth, but sometimes we just need the application. For our project, we are going to use a design that has been created before, and it works pretty well. But this is something that we did previously, and it works just fine. So you can be sure that this is going to charge your devices or whatever you need for your project. So let's start with the schematic design, and this is a schematic design. So as a electronic engineer would actually get all the pieces that are needed for the charger. Basically, a charger, it just obtains the electrical energy from a source. It can be a solar panel, a windmill, it can be any source of electrical energy, and it would regulate that energy for an output. And basically, what it does is that here we put an initial source, the panel, and we have this connector because we're going to use it later. Then after that, after this part, we're going to call it the positive end of the source and the negative. Okay. Now the positive goes straight to a capacitor, and this capacitor is going to smoothen the signal. Okay. Remember that every time that you have electricity, if it's coming from the outlet of your house, you're going to have a sine wave. A sine wave that has a frequency of 60 hertz, and it is not visible, of course, but if you want to charge something from the outlet, it is impossible because you have something called AC power, that is alternate current, and you need to transform that into direct current, that is DC, and that is the one that helps us charge our appliances. In this case, this solar panel will do a little bit of a transformation, but he will give our circuit about he'll give our circuit about 12 volts, between 12 and 18 volts. Okay. Now our appliances like a cell phone can be charged just with 5 volts. So we need a second device, and this is this part over here. And where you see VI, it's voltage in, voltage out, and ground. So it's very important in electronics that we understand what is the voltage coming in the device, what is the voltage coming out, and of course the ground. And as we see, the ground is usually connected to the negative pole or to the negative side of our source. Okay? Now this regulator is going to come in 12 volts, and he is going to lower this voltage to 5 volts. And he is also going to leave that signal completely linear. Okay, that's the idea. At the end of this, we use a second capacitor to minimize and to reduce any any signal that can be noise. Okay, so we want to reduce the noise maximum. Okay, after this, we're going to have an indicator, and this is the LED, and this is the symbol for LED. And LEDs have polarity, okay? And this polarity has to, because every LED is in a light emitting diode, and that's what the name stands for, LED. And as a diode, it has an anode and a cathode. These two indicate the polarity of the LED, of the LED. So basically this part, as the symbol shows, this part is the negative, and it's connected to a resistor because LEDs, if you connect them to 5 volts directly, it will probably burn. Okay? They only use 1.5 volts. That's why we use a resistor, that this is a passive device, and this device, what it does is that stops the flow of current and minimizes the amount of current going through that branch. Okay? Basically, that's what it does, and it reduces the amount of current, so this LED is not burned. Okay? So this is just a simple indicator saying that there is voltage coming out here, and it's charging. The next thing we need is that there is a USB, because we need a USB port to connect our devices, and we need a USB to take the 5 volts to the different appliances, and we connect it directly to those 5 volts. Okay? So basically what this is doing is that it's charging a battery. Okay? It's charging a battery, and this can be the battery connected, so we can use a battery here at the same time, so we can charge the battery and then connect our devices to the voltage of the battery. Sometimes we are going to need the solar charger, even though there's not that intense solar energy, or we don't have enough solar power. So we are going to use the battery. But every time that the panel is receiving that solar energy, he's going to charge the battery. So that is basically how it works. So this is the schematic design. After you do this as an engineer, you pass all these devices that they are on a schematic method to a block method and to the real elements. Okay, and here we have, and you will get a PC board like this. You're gonna get a PC board. This is the top view of the PC board, and you're gonna have a couple of holes on it, and all these elements are the ones that we were talking about on the schematic design. Here we have connectors, and here you're gonna get also this Word document, so you can see each of the devices and each of the parts. Now we can see that there's the solar panel. We're going to connect it to this connector over here. We have the regulator that has 3 pins, 1, 2, 3. So this is a 7805, and this reference basically says that it's a regulator that will have a voltage output of 5 volts. Okay? It will also hand 1 ampere. The maximum current will be 1 ampere. Okay? Then we have the 2 capacitors. There's these little round devices over here. Okay? And these capacitors, the reference is 104. So they're very, very small. They're about 0.01 micro farads. 104, it's 0.01 microfarad. So that is basically the reference. Here we have a resistor. This is going to be the resistor that is connected to the LED to reduce the current flow. And this is the LED. Now this is a 220 ohms, and resistors are measured in ohms, okay? And that is the amount of current that can flow through that device. So you will have all these devices. You will have all these devices in the bag, and the different connectors. Okay. Here we can add this space over here where you have the holes. It's a switch. Okay. And sometimes we would want to charge or just stop the charging, and we can use it with a switch. And this is the reference, but you're also going to get that switch. Okay. Without a problem. So that is basically it, and we also have an output, a 5-volt output, and of course our USB connector, and this is where we're going to connect our devices. If we need 5 volts in a different type, not USB, we can connect it here so we can charge any other device that is not USB. Okay, very good. So you're going to get this. All the holes are opened on this PCB board. You're just going to put in all the elements. And after you put in the elements, you have to solder each part. Okay, when you turn around your PCB board, you're going to see something like this. Basically, it's going to be all copper, and the black part that you see here, it's the copper. After a process um, of printing and a process using chemicals, what the chemicals do is that they take off everything that is not black, okay? Everything that is not black, it's taking off the PC board. And at the end, you will have something like this with all the connections. Now, this design is the same as schematic design, but taken to another format. And that format is it's what is in real life, where you have the components, the real components, and the dimensions. Okay, so the size has to be perfect when you're creating these type of designs, and that's basically what an electronic engineer does. He designs these circuits, design different applications, takes it to a PCB board, and then just prints out the final circuit. Okay. Of course, if we are talking about designing computer boards or industrial boards, this part is done mostly by robotic arms and very industrialized processes. In this case, we're going to do it in a very traditional way because we are building a small circuit. Okay, so all these holes are already opened. Okay, and you can put all the elements there. When you have the elements, you will start soldering each element to this part. Okay, you have to make sure that the soldering does not touch another part because that will be a short circuit. So make sure that when you solder, it is a very small amount of soldering. Okay? Of course, we will be talking during class about what are the techniques for soldering, and that way we can build it nicely. It is very important that you are extra careful because that will completely damage your charger if you have a short circuit. Okay? So that is basically it on how to assemble and how to create your solar charger. Remember that you're going to get the kit with all the parts and your PCB board.